It'll be recorded. Usually it's not that valuable to watch the whole recording, I would say. You really don't want to miss class. If you miss 4 classes, I can drop you automatically. No questions asked. I don't because I'm too lazy. But I've seen in the past students with 4 or more absences just fail anyway. So I just don't have to do paperwork. But you don't want to miss class. What's calculus? Anybody know? I have paper up here if you need it. There's paper here anytime you need it. Even if you're doing homework and you don't want to go pay for paper, you'll see you'll be doing one homework on one page, one homework problem on one page. So if I ask you for 10 homework problems, 10 pieces of paper. Bring paper. If you need it, take it. Okay? What is calculus? Calculus is a pebble, or like a kidney stone, as we call it. Right? So the picture, if you want to imagine, is me dropping a little stone, the calculus, into a pond, and then what do you see in the pond? A ripple, yeah. So it's a circle, right? And what's changing? Diameter changing? More. Area changing. What else? Circumference. Radius. What else is changing? Remember, I'm standing there by the pond, right? I'm getting younger. Time. So what we're talking about in calculus is how one thing is changing, one variable is changing with respect to another, right? So the area of that circle in the pond compared to time, right? And so what is that? Change in area over change in time. What is that? What do we call that? It begins with a S, ends with a lope. Slope. Thank you. Very good. I don't know how you got it so quick. I can't hear that well, so you do have to yell at me. This year is almost gone. So yell at me, please. If I give credit to someone else because I didn't hear you, I'm sorry, but yeah, I mean, my girlfriend's essentially yelling, "I love you" as loud as she can, and then it's trying to acknowledge that she hear people scream that they love you. So slope, right? Slope is what we're talking about in calculus. How one variable changes with respect to another. And so it's a nice little picture here. Do I have my other picture open? No, I closed it, I guess. But a nice little picture. I'll just create it real quick. This is Sketchpad. Nope. So new sketch. I want to look at my window. I want to plot a graph. Do we like trig? Do we like trig? Anybody likes trig? You're in trouble. You need to lie to me. Anybody like trig? Good. That's where you should be. I don't care if you're lying or not, but you need to know how to do trig. Okay? So if you skip trig or you test it out of it just to not take it, go back and learn it. Go take the Khan Academy trig course, 8 hours at most, okay? Here's my function sine of x. What I'm going to do is I'm going to pick a couple of points on my axis. So there's 2 points. I'll label them A and B. I want to find the heights of those points on the curve. So what I'm going to do, is just create perpendiculars to my axis. Can you see it all right? And then find those heights on my curve and connect with a line. I'm going to hide some stuff because it's just messy. I should be able to zoom in. There we go. So what I'm interested in is the slope of this particular line, right? And I can certainly calculate that slope easily, right? We know how to calculate slope, right? But what I'm interested in is moving my point. Where's my point here? There we go. I'm interested in moving point B to point A. So right now I have 2 points, right? And I can calculate that slope easily. Yes, you agree with me, right? 2 points, so you can calculate the slope. So, but what I'm interested in is to calculate the slope at 1 point, right? So as I move point, edit action, movement. As I move point B to point A, when they become 1 point, I lose my line, right? So what we're trying to do in calculus is instead of having a curve, have a bunch of straight lines stitched together to create the curve, right? For example, let's see, circle, point on the circle, point not on the circle, segment, midpoint, perpendicular, trace. Where's my trace? I want to move my point zero. I'm trying to just change everything else to 0. Oops, sorry. I can just do it this way. So if I trace, you see, I get an ellipse. If I move this point outside the curve, I get a hyperbola, or a cooling tower, right? You see Homer Simpson works at the cooling tower there, you see it? So using straight lines, I can get very, very complicated curves. So that's what we're doing in calculus. So we take a very complicated curve, reduce it down to a straight line, and then we know everything about it. Okay? So that's our first goal in the class, is to be able to calculate a slope with 1 point. And we do it with limits. If I go back to my curve here, oh, there it is. Sorry. If I go back to my curve, wherever it is. Sorry. Come on, Robert. No, it's fine. I can use this one. This is the one I created before. So if you look at my slope right here between C and D, I've got a negative 0.2, right? Negative 0.116, negative 1.42. And if I go to the other side, I see a negative 1.86, get closer, 1.72. It looks like I'm getting pretty close to 1.6 on either side. And so calculus, that's what we're going to do. We're going to make predictions. So I'll walk halfway to the wall. Not there yet. Halfway to the wall. Not there yet. Halfway. I can keep walking halfway. I'll never be there, right? But can I get to the wall? Yeah. So the idea is we're going to take an infinite number of steps, which of course can't be done, and try and predict the future, right? And we'll have a very precise way to do it. That's not with a prediction, but we'll be able to double check our answer using that kind of prediction, right? So, limits. How are we doing here so far, okay? So calculus, study of change, turning things into straight lines, and predicting slopes, right? So far, that's what we're talking about. Let's do a limit right away. So our first limit, let's see, the limit as x goes to 2. If you need paper, it's up front, of 2x minus 1. Anybody know that answer? So I guess I should tell you what a limit is. Limit is the height of a function. So can I get the height of this function? 3, right? So the first secret to doing this stuff is plug in. Just plug in. If you can plug in, okay? We'll talk about when I'm allowed to plug in. That's when the function's continuous, so that's a little bit later. So if I can plug in to find the height, that's what I want to do. So informally, my definition, the limit as x goes to c of f of x is L. L is the predictable height of f of x as x goes to c. So graphically and numerically, these are very easy. I never test on that, okay? So, but I certainly could look at the graph here, right? And right when I get to 2, I should see the height of 2, 3. And we're going to use Desmos, by the way. So if you can all log into the computer, that'd be great. We'll use Desmos almost every day. We'll use it during quiz and tests, okay? Your login, but for the computers in front of you, is the same as your email. So the username is your email, right? And the password is your email password. You should have, especially the early college students, should have some notice about that. Today, I don't care if you use your phone or use a personal computer, but during tests and quizzes, you have to use the computers in the classroom. So I'm going to Desmos here. And if you don't get in right now for this one, we'll do a couple of them today. I'd like to look at my function f of x. And I already saw that the limit was when x got to 2, the height should have got to 3, right? And there's a perfect way to see the limit. I want to kind of imagine myself walking on this hill, climbing this hill. So if I'm climbing this way, what height am I getting to? I'm getting to a height of 3. And if I'm climbing down, I can't reach it. Again, I'm getting to a height of 3, right? So I want to be thinking about making sure I get to the same height from the left side and from the right side. Numerically, we can do this limit on Desmos. And what we want to do is get really, really close to 2 from the left side or from the right side. So for example, 1.9 gets really close to 2 from the left side, right? 1.99 gets even closer. And 1.999, I call this gas station money. Does that make sense to anybody? The gas station thing always has 3 decimal places, trying to sucker us into not thinking it's right. $2 a gallon, I wish. But you can see it's pretty clear where I'm going. I think that's really good. If I can't make the prediction after 3 of those decimal changes, quite possible the limit doesn't exist. And we'll look at a bunch of those later. I want to check from the other side. So what number should I check? $2 and how much? Well, 10 cents is close, right? 1 cent is closer, yes. But I really want to try and see what happens if I get to that gas station 2.001. And you can see how close I'm getting to that blue point. So I can clearly guess at this limit, right? Yes, you with me? Other limits are not as clear, okay? They'll all be clear graphically. They'll all be clear numerically. How do you find it if you don't do that? That's the tricky part in calculus. It's a lot of algebra. So let's look at another limit. So the limit is x goes to 2, just because I feel like it, sorry, of x squared minus 4 over x minus 2. Pretty easy to find graphically. This one turns out to be a limit of 4. So in Desmos, I'm just changing that function to be x squared minus 4 all over x minus 2. You can already see my table is predicting already, right? Predicting a height of 4. Yes, you with me? But look at the graph. The graph is weird. Look at the graph. What's the graph look like? Look at the function, look at the graph. The function is polynomial divided by polynomial, right? Well, x squared divided by x is going to turn into some linear x. So it looks like a straight line, but the point x is 2 doesn't exist, right? If I plug in 2, what happens? What? I get 0 over 0. It's better than undefined, so worse. Undefined just means when I'm dividing by 0. I'm either going to get positive infinity or negative infinity. But when I get 0 over 0, it's called indeterminate. Sometimes it's 1. Sometimes it's e. Sometimes it doesn't exist. So we have to kind of discover it a little bit. Obviously, it's pretty clear here it's 4. So, but I want to look at this notation. This is the limit as x goes to 2 of star. And star, I'm going to manipulate algebraically if I can. So upstairs I can factor Right? Everybody with me? I can cancel these out, still knowing that x is not allowed to be 2, and I get just x plus 2. This is what I call my replacement function. This is exactly what my other function looks like, but the hole is filled in. Right? You with me? This is the line x plus 2. If I look at Desmos, that's the line x plus 2. Y equals x plus 2. You see, it's the same function. Right? It just overwrote the other one. But on this one, I can plug the 2 in. So that's what I'm working on. So I know that the limit of x squared minus 4 over x minus 2 as x goes to 2 is the limit as x goes to 2 of my replacement function x plus 2. And since now I can just plug in, I do so. I'm trying to come up with a function that will give me the height of my original function, even though that piece is not in the domain. A little weird, so going closer to 2, closer to 2, closer to 2. I already know what the answer is for this. I don't have to go all the way to 2. In this function, I'm not allowed. In this function, I am allowed. Okay? I need my formal definition of the limit. And then we'll take a break and do some other stuff. We say that the limit as x goes to c of f of x is L if and only if for every for every epsilon greater than 0, there exists a delta greater than 0, such that 0 is less than the absolute value of x minus c is less than delta, implies the absolute value of f of x minus L is less than epsilon, obviously, right? I'll say it again, I'll write it out. I'll get you to explain it. Let's understand it. We're thinking we understand this concept, right? It's just the height of the function. We predict the height of the function, right? We're thinking we understand it, yes? Yes? I can find the height of the function, right? But now we're looking at this formal definition. It says for every positive number, epsilon, in Greek letters like a pi, right? For every epsilon greater than 0, there exists a delta greater than 0 such that 0 is less than the absolute value of x minus c is less than delta. It implies that the function minus the limit is really close. Have you seen this before? Anybody seen this before? It's okay. Epsilon, so picture the archer shooting at that big white target in the field, yes? You with me? Anybody not visualize that? Right? Shooting that arrow at that big target, and the middle is what color? Red, the bullseye, right? Yes? So, what I'm saying is, for every target I have, picture a target, I can find a bullseye so that if everything within that bullseye stays on the board, I get the limit. Let me show it to you this way. For every target, yep, if I can find a bullseye such that restricting my function stays on the board. So if I find the right width, right, so such that the function that I'm using, f of x, stays on the board, what am I going to do? I'm going to shrink this epsilon down to 1. shrink the board down to what? Every dartboard, every part. I'm going to shrink it down to what size? Yes. Every single bullseye. What size do I want to shrink it down? Almost nothing, right? So that if I still hit it, if my pieces of the function stay on the board, what must it do? It must hit the center. There's my limit. Let's see. The limit is x goes to 2 of x squared. What's the answer? Yeah. This is the same as for every epsilon greater than 0, let delta equal epsilon over 5 such that 0 is less than x minus 2 is less than delta implies f of x, which is x squared, minus 4 should be less than epsilon. Now, the epsilon over 5 I came up with, and you will not be responsible for coming up with the epsilon. Remember what I said, no matter what dartboard I take, there must be an epsilon that works. Here it is. So there's my function x squared. X is 2, height of 4, right? I picked a to b is my epsilon. My epsilon. Radius green. A to c is the radius of this step. Right here, A to c. I picked it about a fifth because I know that works. But look at the part of the function that's within my restriction of delta. You see here's my delta? And look at the dark part of the function. That's the part that's down between those two pieces, minus delta plus delta. Right? Now watch what happens when I shrink down my board. If I shrink down my epsilon, notice all of those dark blue pieces are still on the board, correct? What happens if I go all the way to 0? Right? What happens if I go all the way to 0? I hit the bullseye. Guaranteed to hit the bullseye. I got the limit. Watch what happens if I use a different delta, sorry. So I'm going to use something like epsilon over 2. Oops, ugly, sorry. Epsilon over 3. You see the top part of the function is off the board. You see the top? When I'm restricting between this distance, the top part is off the board. So when I shrink it all the way down to nothing, I miss the bullseye. Does that make sense at all? All right, let's go. I might have scared you a little bit. I'm sorry if I did. This piece is important for the understanding, not so much for being able to do the problems. That's all I want you to be able to do is the problems. Okay, so let's talk a little less nerdy for a second. So you should have access now to Blackboard. And I will invite you to read the syllabus. Not that you have a choice, but we're gonna take 4 exams, a chapter 2, a chapter 3, a chapter 4, a chapter 5 exam, and a final. So we take quizzes every day, starting next week. What else? Homework, which I'll talk about in detail. A project, which is a nice computer science project. Sorry about the non-computer science majors in here, but still good for you. And then the extra credit, 5% extra credit for doing a study group. On your honor, you don't have to prove to me that you're doing a study group, right? So if I go to Blackboard, yeah, this is our class. I've got a bunch of things up here. Obviously, the syllabus is here. You should read it. I don't need to read it to you. I don't know why teachers do. Teachers read you syllabi? I hope not. The most important thing that's in here is, of course, my contact information. So there's my email. I only want you to email me directly. So like I'm going to show you WebAssign today. You can email me through that. Don't do that. You can email me through Blackboard. Don't do that. Just write me a direct email. Okay? So that's the only thing I really care about in the syllabus. Everything else is there. Read it and then get back to me if you need to. The grading is there. I talked about that already. 4 tests. 30% each. A final exam at 40%. Ooh, right? Homework is 20%. That's a freebie. Projects 10%. That's a freebie. 5% extra credit. Again, there's no reason for you not to have 100 on that. Okay. Yeah, and the only day you definitely don't want to miss a test day. You don't want to miss any day because I'll have a quiz every day, but I'll drop a bunch of quizzes at the end. So if you had to miss a couple, it's fine. The schedule is here. It's not quite ready. As I go, I will update things. By third or fourth week, I should have before your first test, I'll have everything updated. Okay, but the schedule is there. Just not quite ready. So if you'll see here, the first day says introduction and limits, right? Question. When is the first quiz? Monday. A week from today. And it's on algebraic limits, numeric limits, graphical limits. So I'm going to do a bunch more today and a bunch more Wednesday. You'll have some homework assigned. You'll be able to ask me about it. Then the very next day I can quiz on it. I won't teach you something and then quiz the same day or the day next day. I'll always give you a 1-day lag before I assess you on anything. Let's see, what else is here? All my old exams are here. All my past exams are here. All my old Chapter 2 exams, Chapter 3 exams, midterm exams, Chapter 4 exams, Chapter 5 exams, final exams. They're all there. Make sure you do them all. Okay? They're all there. There's review packets, etc. Everything is there that you need. And if you look at announcements, anytime there's something important for me to give you or tell you, I put out an announcement. It'll go directly to your email. If there's a file in there, like a test solutions, you can't open it until you log into Blackboard. Okay, just so you know. But so here you can see I've got, this is from spring 2022. So I've got their exams in the announcements, right? So you certainly can look at all of them as well. I talk about how you can get help, right? talk about how you can get help. There's Dr. Early. He's our embedded coach. He'll be here Friday to talk. But you can ask me questions during class. You can email me, and that's what I prefer before class. Like you want me to do section 2.2, number 7. I don't want to have to look it up in the book. I want to look at your email and know what the problem is that I have to do. I'd also like to see your work there and maybe a comment. Not sure why I'm getting this wrong. And if I look at it and I go, oh, you said x squared is, you said 2 squared was no, you said 3 squared was 6 instead of 9, right? And then I don't have to do it in class. I can just send it right back to you and you realize you just made some silly little mistake, right? You can go see, you do a study group, go to the Math Learning Center, and there's also online tutoring. So there's lots of ways to get help. The other thing we have is WebAssign. And let's work on that now. So if you can go to webassign.net for me. And it's going to ask you to enter a class key. I'm going to give you that class key in a second here. This is where you're going to access your textbook. And online practice if you want it. If you see here, I've got 24 assignments throughout the semester. These are optional. Do not have to do these. They are optional. I want to see your writing as soon as I can, so select homework and grade it. The computer's there if you want to just try, hey, give me another problem and let me try again, right? So we tend to, as humans, we have the tendency of not writing when we're doing stuff on the web. I want everything written. Right? So again, this is optional. How many of you like things like Math Excel and WebAssign and Alex? And so it's there for you if you want to use it. You've got to make sure, because WebAssign is a little bit too easy. You got to make sure you do my problems, do the problems I give in all my old exams, right? Okay, here's my class key. Let's sign up. This is free for 2 weeks, so don't pay for anything, okay? Don't pay for anything for 2 weeks. If you have the money, meaning you're getting money from the school or from Montgomery County to buy the book, okay? I personally like to throw my book at times when I get mad. So if I only have the digital copy, it gets really expensive. But if I have the physical book, I can just chuck the book, you know? I hate this class. All right, here's your course code. And it's the word and the numbers. Montgomery College, space 1486, space 3848. Don't pay for anything today. Sign up. It's temporary access. Yeah. Oh, oh, yeah, this one's cool. Yeah, no, I get it. You usually you can read. Yeah. It's up to you. Do anything you want. band. So yeah, at one point it's going to say 8, get an access code, and there's a little link at the bottom that says temporary access code. Anybody? Yes. Give you a few more minutes. I want to show you around in here a little bit. I'm trying to get an outlet. Yeah. You want? Cool. You see the junction box there? Yeah, there you go. How we doing? Anybody there? Not yet? Yes? Say again? Nothing. Just want you in there, and I want to show you around a little bit. You can search around a little bit if you want. So once I get in, I should be able to see, oops, sorry, there you all are. So once you get in, you should be able to see the assignments. These are not going to be graded. I am not grading these. This is for you, for that option. If you like using, right, the electronic homework system. But you still have to hand in the homework for the national degree by them. Yes, is that clear? The first homework assignment is probably due in 2 months. Okay. The book is also here. You can see that link to the book right on the left-hand side there, ebook. I would like you to start reading chapter 2, 2:1, 2:2, 2:3. So that's your only homework for tonight. I won't get to problems yet. You can access the sidebar, right? Chapter 2, start reading 2.1, 2.2, 2.3. Okay? Everybody with me? Yes, question? Yeah. Start reading 2.1, 2.2. You can access this book in the library. So if you, right? Go to the library with your study group and do problems there. Obviously, you can take a picture of it. You can access the book in the Math Learning Center. It's in the Math Learning. You can just go in there and work if you want. And you can access this here. Don't pay for anything yet. They promised me $50. It was $140. We changed the edition, so they told me $55. Don't pay for anything until I verify the price, okay? If you're going, so you're computer scientists, my early college students are computer scientists, you are taking Calc 2. So in that case, since Montgomery County is paying for your book, go buy the book at the bookstore. It'll have the code in it. Doesn't matter what they charge. Yes. Yes, exactly. So that is code only, and that's fine. if you go to the bookstore, you can get the book, a binder version, and the code. Okay? If you have questions about that, please talk to the early advisor. Who's your go-to person for early college? Is it Jennifer anymore? Huh? Say again. Oh, Jennifer resigned? Okay. So do that person yet? Still with kindness, whatever you do, right? So you certainly could reach out about books and all of that. Yeah. So the call. Yeah. The access code exactly as exactly. Don't do it for 2 weeks. Wait for 2 weeks. The problem is that they don't pay for it, and the paper itself to actually content. No, that's fine. Mike? It won't be a problem. There's a code on the back. You call them and they'll be able to. Okay, we'll figure it out. That's 2 weeks. So don't worry about it. 2 weeks, okay? Okay, we know where the book is? Yes? We know our homework already? Start reading 2, 1, 2, 2, 2, 3. How do you read a math book? With paper and something to write with. So when they start doing an example, you do it. And they'll may skip a couple steps. Hopefully you could fill in what they're doing, right? Okay, next. Don't tell me. Talked about the book, talked about homework, talked about quizzes. You got all my old tests, right? The homework is here, but it's not updated yet. Please just wait with me, right? You're not going to miss class, so you don't have to send me an email. What's the homework? When I get it updated, I'll say homework 1 is ready, right? So if you look here, homework 1 is 4 problems right now. You probably could start them today, maybe not. But in the section, I'll tell you, I like problems 1 through 55, right? So meaning you're looking at problems 1 through 55 informally, because they start easy, right? And then I'm going to say, hey, but turn in number 33, number 53, number 55. Right? Does that make sense? So, but wait for me. Let me make sure. If you just got a new edition of the book, I'm not sure if the questions are matching up the same. But just wait for me. I'm kind of easygoing about things, except for the math. You have to be able to do the math. You have to be able to do the rigorous math. Everything else is okay. Okay? Life is hard. You don't have to make it even more difficult. Math. You have to be able to do the math, right? Okay. Questions for me? Yes. Say again? Yeah, I asked you to do the temporary, right? It's not working? Yeah, temporary's not working? Yeah, no, close it. Should you log in? And if you're a class, you put the access code to the classroom. Yeah, show me. And the course key would be course key. Again, okay? There it is. Take a photo real quick if you can for me. But sometimes, yes. Yes. Always on paper. Yes, everything we do for a grade will be on paper. We have class Monday, Wednesday, Friday. Is Monday a holiday? What's Monday? I don't think we have Labor Day off. Hold on a sec. I think the only thing we have off is we have Labor Day off. Just in time. Just when I was feeling burnt out. I know we have Thanksgiving break, so I'll double check. Quizzes will always be straightforward. I'll say to you, we have a quiz tomorrow, or next class, that you have to factor to find the limit. And you'll see me do a bunch of this question. Blackboard isn't working for you? Yeah, oh, I see. I would contact the help desk. So, and this happens every semester. So, right. So if I just go to the main college website, and then I do IT help desk, there's a phone number, there's a chat, there's an email. I would just call them. And kill them with kindness, right? So maybe someone's cat died and they're being a little grumpy. Just right? Okay, I'm sorry. I'm trying to log in. I'm having trouble. Can you help? I think you call in and says, are you a student or faculty? They transform you, and then there's sometimes a wait time. So again, just be patient. It should be. I mean, of course, nothing's easy, right? We just have to realize that. Oh, here it is. Contact the IT service desk. There should be. Why is there not just an easy way to look at the phone number, right? Here we go. Chat, call. There it is. There's the phone number. Can't get into Blackboard, can't get into your email, can't log into a computer on campus. So they should be able to help you with all of that one time. Cool. We're feeling pretty good about how the class is going to go. Start with homework questions. I'll recap old material. I'll teach new material. We'll quiz. Basically every day of the semester, except for test days. On test days, always on Friday, test for the whole period, for the hour and 25 minutes. Okay? All right, let me see who's here. IPSA. Yes, I say that right? Early college, yes? Good. Ephraim. Yes? Early college as well? Nice. Cheryl. How do you say it? Chris, you got it. And you're doing civil engineering? Beautiful. I wish I did that. Build a bridge, build a building. How cool, huh? Caitlin. Nice, Caitlin. Bio? Nice. So the bio students, biochem students, if it's chemical engineering or bioengineering, you're taking Calc 2 guaranteed. But if it's just bio or just chemistry, again, look at your transfer institution, where you want to go, and prepare, right? Jack? Nice. It says STEM, but you told me what? What is it? Civil, nice. I like that. I was a computer science major and then hated it. It wasn't nerdy enough. Hard to believe. Just studied math, but when I got a job later, I was a computer programmer for some high school. So, the computer scientists have it lucky. You could just hack into Russia and be famous and rich right now. You don't have to go to any school. You could create software and sell it. No, again, no school needed. Or you could take the academic route, right? So you're lucky. The bio majors, the engineers, we don't have a choice. We're going through the academics, right? So, Luis Castro, not here? Is it Nathaniel or not Nathaniel? Nathaniel, sorry. Comp Sci, early college, yes? Nice. Jeffrey, nice. Early college, Comp Sci, yes? Yes? Thank you. Matthew. Matthew DeWitt, yeah? Is that how I say your last name? David, thank you. Comp Sci, early college? Nice. Angel Figueroa? Nice. It says general. What are you really though? What is it? Nice. If you change your major, the computer science department gets more money. So do that. If you want to see how I change my major, again, I'm just going to the school website and declare major. There's one form, you turn it in downstairs. Change your program of study or declare or change program of study. It's one simple form. You can print it right here, fill it out, bring it downstairs. Okay? Anytime you want to print something, these computers are all hooked up to that. Feel free. Anytime you need paper, take it. You need paper for home to do homework. He's making me do 10 pages of homework. I'm grabbing 10 pieces of paper, right? So, please. Felicia? Nice. I say that right, Felicia? Business major, yes? Make sure you are looking at, do you need to be in this class? I pretty much can tell you, you don't have to be. It'll still work for your degree, but you will work a lot more than you would in a business calc class, okay? So just take a look at that and talk to me if you want to. Anything you have questions about in the school in general, please feel free to talk to me, right? It could even be, look, I'm struggling right now at home, etc. I'm not going to give you any advice. I'm going to put you with somebody who can give you advice or help you, okay? You say to me, I just can't do this factoring. That I can help you with, right? So that one I'll take on. But if it's some problem you're having, right? I mean, anything that could be going on in anyone's life, there's someone here to help. Food, mental health, just organization. You can have a personal coach that will help you get organized if you have trouble with that. So you just let me know. Anissa, where are you? Thank you. Computer science, early college, yes? Misker, I say that right? That's a cool name. You're doing biochem? Double check about the Calc 2, okay? All my bio students, all my biochem students, all my chem students, business students, do I need to be here? No, you do. Biochem, you need Calc 1, Calc 2. Maybe Diffie Qs. Okay, lots of math. Any kind of engineering is lots of math. The only way to have more math than an engineering class is to be a math major. Ariana? Nice. I say that right? Bio. Good. So like if I go to and I do the bio degree here, right? So I go to the school website and I do biology major, right? And I don't want to scare the students that are in early college. They've got your whole semester planned out. But if you are transferring somewhere like UMD, College Park, and bio, and they are going to make you take Calc 2, you want to take Calc 2 as an elective here. Does that make sense? And don't wait too long. I think fall to summer is fine, but you have to make sure you know chapter 3 in calculus and chapter 5 in calculus to do well in Calc 2. So even if you're doing it fall to spring, you make sure you review in question. Say again? 3 is derivatives, 5 is integration, antiderivatives. Chapter 2 is limits, so we can learn how to do derivatives. Chapter 4 is applications of derivatives. Boring word problems. Brian, business major. Again, double check. Oh, biology major, sorry. So bio major, right? Same thing, business major. Click on it. You will see halfway down the programming advising guide. If I click on that, it will tell me what classes I should take. Again, early college, they have it planned differently than this, okay? So don't freak about it. But you can see here, I've got a Math 181 here. There is no other math. But depending on where you're transferring, you will have to take Calc 2. It's where Calc 2 is where some of the interesting applications for biology. Okay, so just be careful of that. Laura. Laura Nanguieri? No, not here. Louis not here also, correct? Louis Castro not here. Luis. Molly. Nice. Early college comp sci, yes? Chrissy. Early college comp sci? Nice. Chrissy, have you seen epsilon delta before? How did I know that? Candace. Candace, hey. Bio, yes? Petra. Biochem? Engineering or no? Okay. Diara? Did I say that right? Nice. Aerospace. Nice. That's far out. I forget how to say it already. Tie? Toe? How do you say it? Say it again? Hoyt. Oh, wait, thank you. Electrical engineering. Yes? You can't, the old joke is you can't spell geek without EE. No offense, I'm a geek too, so. Elizabeth. Nice. Early college comp sci, yes? Beautiful. Chowdhury. Nice. And STEM, but what you told me really what? Chem. Yeah. Beautiful. I am Robert. Please call me Robert. I'll get your names as soon as I can. I typically, yes, question? Robert or Professor Kuhar is fine, or Yo. I lived in Brooklyn for a while. He would call me Yo is Philly, Mo is Brooklyn, whatever you want, really. I just don't like Mr. Kuhar. That was my dad. He was also a math teacher. He's passed, though. So now I call him, instead of Daddy, I call him Daddy. It's a joke. When my mom finally goes, I'm going to just wrap her up and call her Mummy. What do you think? Any questions for me? We know how we're getting graded. We know what we're doing. We know what we're doing for Wednesday. Yes? Good. Let me do a couple more problems and we'll quit. We've got about 10 minutes left, okay? I want to do a bunch of algebraic problems so that you can start these limits in 2.3 that I have assigned, and you can start the first homework assignment on WebAssign. Again, that's not graded, okay? So, but we want to talk about algebraic limits. And there's basically going to be some factoring, some LCDs, and some conjugates. It might be a combination of two of those, but you want to think of them in this order. If you can factor first, factor first. If you can clear fractions, right? Fractions within fractions, that makes sense? If you see a radical, see if a conjugate will help, okay? Square root, right? So let's do some factoring ones. These are all about replacement functions. So let's look at the limit of x cubed minus 8 over x minus 2 as x goes to 2. I like to say that this is the limit as x goes to 2 of star. First of all, notice that when I put the 2 in, I get 0 over 0, right? And there's that little side note. 0 over 0 is an indeterminate form. When I get 0 over 0, obviously I can't go all the way to 0 over 0, right? I can't take this limit. I can't go right to 2 because I'm dividing to 0, right? Can't do it. Even worse, 0 over 0. So in this case, I plug in my 2 and I realize it doesn't work. My first thought is always plug in. Second thought is, can I come up with a replacement function, right? So I like synthetic division on this. If you don't like that, I'll do long division as well. Or maybe you can just factor it, right? But I'm going to try and put 2 into 1x cubed, 0x squared, 0x minus 8. So I'm doing synthetic. How many of you remember synthetic from pre-cal? Synthetic division from pre-cal? Only one of you? I'm scared. So I bring down the first, and then I diagonal multiply, so I get a 2, and then vertical sum, so I get a 2, and then rinse and repeat. So 2 times 2 is 4, add 4, 2 times 4 is 8, add 8, 0. So I get x cubed minus 8 over x minus 2 is x minus 2, that comes from here, times an x squared plus 2x plus 4, that comes from here, all over that x minus 2. And I can see that this piece cancels, and there's my replacement function. I like doing these on Desmos, even during a test or quiz, even during homework. So I can really see that I'm correct before I go waste more time. I want to kind of, take 2 steps, 1 step back, 2 steps, 1 step back. It takes me longer, but I'll be safe. So I'm really looking at Desmos, and you can do this with me. I'm looking at that first function, which is my whole function, right? Which was what? X cubed minus 8, all divided by x minus 2. And then I got my replacement function. Now remember, there's a hole in this function at 2, right? I got my replacement function of what? Tell me, x squared plus 2x plus 4, is that right? And look at the replacement function, it's identical, right? But the original function I cannot plug 2 in. The replacement function I can plug 2 in. Why don't I care about not being able to plug 2 in? Because when I'm walking halfway to the wall, do I have to keep doing it? No, I already know I can get to the wall. So use the easier version, plug into that one, right? So meaning, right, I've got my limit as x goes to 2 of star, which is the limit as x goes to 2 of x squared plus 2x plus 4, which is 2 squared plus 2 times 2 plus 4. Notice once I plugged in the number, I'm not writing limit anymore. So what do I get here? 12? And now I'm going back to my Desmos. Everybody okay? If sometimes I'll start writing too fast, and if I start writing too fast, just tell me. Huh? If I start writing too fast, tell me. I'm writing too fast, thank you. Joke landed. So, but I'm going back to Desmos, and I'm plugging in 212, right? 2 comma 12. Boom. Got my limit. This easy. It's easy. You'll see there's lots of stuff in calculus that's very, very easy. The algebra is not. You want to see the long division on that one? Anybody want to see the long division on that? Yeah? Nice. So I'm doing x minus 2 into x cubed plus 0x squared plus 0x minus 8. And I'm asking myself, x times what will get me to x cubed? X squared, right? Then I come back and multiply to everything. So I get x cubed minus 2x squared. I change my signs and add. So I get 2x squared plus 0x minus 8. Rinse and repeat. Right? So what am I asking now? I'm asking x times what? Right? X times what will get me 2x squared? That's 2x, right? Come back and multiply. Change the signs and add. Rinse and repeat. Yes? X times what will get me to 4x plus 4. Look, you see it already? You see my factoring? Come back and multiply. Change my signs and add. Done. How many remember long division from pre-calculus? Good, long division will always work. Synthetic division won't. Okay? So I'm fine if you only know long division. I'm also fine if you just know how to factor this, if you just have it memorized. Beautiful, let's do another one. We're almost out of time, 3 minutes left. I find 200 milligrams of like Advil right before, 10 minutes before class, does the trick. I'll warn you on the days where you need the 400 milligrams, okay? So just bring a couple of extra with you. Here we go. The limit of 1 over x minus 1 over 2 all times x minus 2, all over x minus 2, as x goes to 2. I don't do every limit at 2. I just, I don't know what happens. I get stuck sometimes. So first of all, if I plug this in, do I get 0 over 0? If I plug it in, do I get 0 over 0? Yeah. So I can't use it. I can't plug in. I have to find a replacement function. This is my thought. So I know my current function has a domain of not 2, but if I can come up with a replacement function, and on this one I'm going to use the product of the interior denominators. So I'm going to do 2x over 2x. This will clear fractions. If you remember this in pre-cal, it was called complex fractions. When I have fractions within fractions, I always want to clear them the whole semester. That will stop in Calc 2. But for Calc 1, if I have fractions within fractions, fix it. Make it look better. Use the LCD over itself. What am I actually multiplying by here? In purple here, what am I multiplying by? 1. I'm allowed to multiply by 1. I'm allowed to add 0. Pretty much nothing else. So our trick is to multiply by 1 here to clear fractions. I get 2x over x minus 2x over 2 all over 2x times x minus 2. Is everybody okay there? Don't let me go too fast. I can clearly see that the 2's will cancel here. Oops, sorry, that's 2x over x, sorry. So my x's will cancel there, right? And my 2's will cancel here, and then I rewrite. I've got 2 minus x over 2x times x minus 2. My teacher used to make me factor out that negative from upstairs. I don't care if you just see that the opposites cancel to -1. Everybody okay here? Nice, I'm ready for my limit. The limit as x goes to 2 of star is -1 over 2 times 2, so -1/4. I'm out of time, I'm sorry to say. But I look forward to seeing you Wednesday